Okay, time to practice it with numbers now. Let's see. Determine the normal force on the 10 kilogram mass in each of the following situations. So, normal force is a force. Let's go ahead and free body it on up. Do we have any friction? None that it says, so we're going to continue on the normal force, and then we're going to connect it, and this angle here is going to be 37, so it's going to be mg cosine 37, and this will be mg sine 37 down here. Okay, theta. That's good. All right, so normal force. I don't really even care about this mg sine theta because we're only looking for the normal force. Normal force, let's go ahead and figure this out. We're not sinking, we're not floating, so normal force is just going to equal this component of the weight force. mg cosine 37. So it's 100 cosine 37. Close enough. So our normal force should be 80 newtons. Make sure you can do this stuff on your own. I just made that perhaps look simple, or maybe I made it look like it was really difficult and you know a simpler way. If that's the case, then do that. Do that. Over here. Same thing, let's get a different color. Black is just, right? mg. We have, I've already explained a lot of stuff. So this is going to be opposite, so this will be 50 sine 37. Didn't we just calculate that and it was like 30 or something? And then this is going to be 50 cosine 37, but we don't even care about that. I think we did 50 sine 37, and it was 30. Hey, good for me. So all of this just equals 30. Our normal force, so we're in the vertical direction, stuff that makes it go is going to be Fn plus 30. Stuff holding it back is going to be the weight, which is 100. And all of that will equal 0. So we're going to add 100 and divide by Fn equals 7. Hey, wait a second. Come on. Same exact problem? Easy. Give me something a little bit more challenging, please. Oh, I can't do both of these in this video. Let's see. Determine the acceleration of the 10 kilogram mass. So we're just going to look at this top one first, I suppose. So we're talking about forces. I know that because it says there's a 50 Newton force applied to the box. If we're talking forces, very first thing we're going to do is go ahead and get that free body diagram going. Cranking it up with the easy one, mg, then we've got normal forces, nowhere near that big. Because we have this. I mean, get real. I'm not going to calculate it again, Mr. Scopetis. I already know that this is going to be 30 over here, okay? And I already remember this is going to be 40 because it's a 3, 4, 5 triangle, so 30, 40, 50. All right. And then I've got friction added. I know that because that little mu. All right, so we've got frictional force here. Determine the acceleration. So we don't care about the vertical forces in this, other than our frictional force has to equal mu times Fn. So what is the frictional force? Mu times Fn, and Fn is going to be, we'll go ahead and do this all. Stuff that makes it go minus stuff holds it back. So Fn plus 30 minus 100, right? Remember? Like 2 seconds ago, 70 newtons. So 0.2 times 70 is going to be 14. So our frictional force is going to be 14. Ff equals 14. Now, if our acceleration is going to the right, Now we can do stuff that makes it go minus stuff that holds it back. So the stuff that makes it go is at 40 minus the stuff that holds it back, 14, equals mass, which is 10, times our acceleration, which is what we're solving for. So 40 minus 14 is going to be 26. Divided by 10 is going to be A equals 2.6 meters per second squared. Don't forget your units. And we'll give it a nice circle so my reader knows where to find the answer. 2.6. That's for this over here. I'm going to erase all this. And I'll 5 hours later. All right. Determining the acceleration here. Starting with a free body diagram. We're going to go here. mg. Then we have tension. Tension. ft. And then what direction is our acceleration? It's going to be to the right. Good. mg is perpendicular to the acceleration, so we're good there. We don't have to resolve, but we do need to resolve our tension force here. So we're going to do that like so. And this will be the adjacent, so this is going to be ft cosine theta. And then this will be ft sine theta. Alright, so to find the acceleration, because the acceleration is directed to the right, we're going to use parallel to the acceleration. So the net force is going to be the stuff that makes it go, which is ft. Is ft not given to us? Sine theta equals ma. Well, nuts, we don't have ft. Let's see if we can get it from the vertical direction. So I'm going to use a different color here. Vertical direction. We have stuff that makes it go, ft cosine theta, minus mg equals 0, because we're not going up or down, our acceleration is to the right. So that means ft cosine theta equals mg. And give me a second, I'm going to plug in these numbers. Looking at it, we don't really have to. So I'm just going to say ft divided by cosine theta divided by cosine theta. So ft will be defined as, ran out of space. So ft is defined as mg over cosine theta. And we're going to take all of that and we're going to plug it into the equation earlier. Whereas ft sine theta equals ma. Ft sine theta equals ma. And we're looking for that acceleration. So we're going to take all of this and just plug that in there. And it becomes this, mg over cosine theta times sine theta equals ma. Well, we can rewrite that again. And we get mg sine theta over cosine theta. Sine over cosine, tangent. And we also have an m on each side, so we can get rid of that m. Simplifying it further, we get g times tan theta equals a. It's tricky. Go back, do it again. If you still aren't too sure, do it again. Take out a fresh sheet of paper. Draw the diagram. Start from the top. Start with a free body diagram. Go through all of the steps until you can do it by yourself. Because you can.